It's garage chemistry time with Miller. That's me.
How's it going today, you guys? We're going to do a synthesis of Aspirin Lab today. So this is a really involved lab. It's kind of intro-level organic chemistry. It's super, super fun. I got my setup of chemicals over here. I'm going to do it in a couple parts, though. This first part, we're going to try to ester. We're going to try to knock off that phenol group on the salicylic acid and add that ester group. It's called an esterification, okay? So super simple. I'm just going to add the salicylic acid to this beaker right here. I'm going to add in the acetic anhydride and then add in a couple drops of sulfuric acid. The acid will be a catalyst to get the acetic anhydride to break up and add an ester group onto the aspirin. Okay, so here's what's actually going on. That salicylic acid right there, and I labeled the phenol group, and then the carboxylic acid you can see is present on both of the compounds. So salicylic acid is the top one. We're going to add that to the flask, and that back in the day was what chemists and doctors synthesized to treat pain. There's some nasty side effects on it due to the phenol group, so that's why a doctor later on, it's totally slipping my name, added, he worked for Bayer, and funny thing is, we're going to test our product against some Bayer aspirin tablets that I have. He added the ester group onto the salicylic acid, thus creating acetylsalicylic acid. That acetyl comes from the acetic anhydride that we're going to use to throw that ester group on. And acetylsalicylic acid is more commonly known as aspirin. So it's the most widely used pain medicine, or just like fever, inflammation medicine out there. And we're going to make it in our garage today. Okay. Here is the reaction that I was talking about. So you have the salicylic acid, the acetic anhydride. That H plus with the arrow means that it's an acid catalyst going on. We're going to use sulfuric acid, some nasty stuff today. And then that bottom compound is your aspirin. All right, first part, let's create this. Second part, we're going to purify it. All right, guys. So what I did is I added on your data table, this is the first data table, mass of salicylic acid. I already weighed out 0.53 grams. It calls for 0.5, so just get as close as possible to there. You never really want to get exactly on it. You want to go over. I feel like if you go over, I don't really like ever going under. If you go over, you know you got your result, and it's a more true number than trying to get 0.50 exactly. Okay, so let's add this aspirin, or not that pre-aspirin. We're going to add that to our beaker right here. Okay, and then it calls for 1 milliliters of acetic anhydride. Now, acetic anhydride, you want to use in a ventilated area, ventilated garage. It's called a lacrimator. What it does is it makes you cry. So if I were to smell the fumes of this, generally it makes me start crying. Kind of weird, huh? You'll get super, super crazy tears, stuff like that. Okay, next we're going to add 2 drops of sulfuric acid. This is concentrated sulfuric acid. It's really nasty stuff. So we're going to add it really carefully, okay? 1, 2, okay. Sulfuric acid breaks up organic compounds, so that's kind of good for us that we're going to be breaking up those compounds in there. Okay, next what we're going to do is I'm going to lower it into my hot water bath that I have here, and I'm going to let it sit for about 10 minutes. So as it's sitting in that hot water bath, I don't want it over the flame generally. I'm just going to have it in that bath so that the warm water will make the reaction go faster, and it'll kind of like liquefy anything that's in there. So I can already see that the reaction's kind of coming together. It's going to take 10 minutes, so I'm going to pause here, and then we're going to come back. All right, you guys, we're back. So it's been 10 minutes of heating now. What I'm going to do is I'm going to take this beaker, I'm going to raise it out of the hot water here, and I can see that my the salicylic acid is kind of dissolved up in there. And what I'm going to do is the entire time I've had this water cooling over here, and I'm going to put in a couple milliliters of water into the flask. Now remember, it's 18 molar sulfuric acid. So when I add this water, I'm going to add about 3 milliliters in. It's going to react pretty vigorously, so I'm going to do it pretty slowly, okay? So... I'm going to stop there for now. I've added about half a mil in. The flask gets really hot with all that acid in there, so I'm going to let it cool off for a sec. I can see that there's heat waves coming up on the side. So I'm going to get another half milliliter in here. Okay, I think it's safe to add the next 2 milliliters. All right, so we have the aspirin right now should be crystallizing. I'm going to put it over this ice bath right here to crystallize it out, which should take maybe 10, 20 minutes just to really get that full effect going on. So I'm going to add about 5 to 6 more milliliters of water into this thing just so I can get all that aspirin. You can see it up on the side over here. I'm just going to try to get it all down into the flask and ready to be filtered out once it crystallizes. So I just need that solution for all that. And what we're doing is we're creating what's known as a filtrate. So we want the crystals that are left behind. Once we filter it, all that liquid, that filtrate, we're going to kind of just toss aside. Now, normally what you do is you try to recrystallize that filtrate, get some of the stuff out of there, and then like total recrystallize what's from the filtrate and what you made before to get like the best yield you can. But for our purposes, add about 5 more mils and let's let it sit for a while. All right, so now that that is sitting in there, I'm going to mix that up a little bit, kind of get that reaction going, make sure everything's settling out. What I'm going to do is I'm going to take that beaker and I'm going to put it in my ice bath and let it sit there for about 10 minutes, okay? And that ice is just gonna kind of cool the solution down, get everything out of the filtrate and then crystallized out. So like I said, it's about 10 minutes for that reaction to occur. Then what I'm gonna do is I'm gonna pour my aspirin and filtrate into this funnel setup I have right here. So in the meantime, I'm gonna get that funnel setup situated. And we're gonna try to get these crystals weighed out to see how much aspirin we actually weighed. Then what I'm going to do is recrystallize. I'm going to show you guys that step just to get a more pure sample for when we do the iron test, okay? So when we come back, I'm going to go through the filter setup and we're going to keep continuing on. All right, guys. And we're back. So I don't know if you can see it, but look at all those crystals all up in there. That is our aspirin that we made. Just took it right off of the ice bath. And now what I'm going to do is I'm going to take this solution and I'm going to filter it through my funnel and filter paper. And then I'm going to use my squirt bottle to get all the rest of the aspirin that's in there because I want a good measurement of how much aspirin I have. Try to get it all out of the beaker, down into the flask and the filtrate. Then I'm going to scrape that filtrate and put it onto my pre-weighed watch glass. Oh, it's not a watch glass, it's an evaporating dish because I'm going to put some ethanol in there and try to recrystallize it in that dish. So, already reweighed the crystallizing dish. And we're going to filter this up and then see how much we get out of this. All right. Now what I'm doing there is I'm using my squirt bottle to get all the residue off the sides of the beaker and get any solution, any filtrate out of there. And what I have left in my filter paper is a bunch of crystals. You can kind of see those crystals that are in there, maybe kind of sort of, just looks clear. But you can see the crystals that are in there. Now, normally, like what I said, we would try to get more crystals out of that filtrate. I'm gonna toss the filtrate for now. I don't need it. What I do need is to scrape those crystals into my evaporating dish. So that's my next step. So it's still kind of wet, but that's okay because what we're gonna do is, even though we're gonna get a mass here, I'm gonna get the filtrate out of there, and it's gonna be a rudimentary mass because I'm gonna recrystallize everything, get a brand new mass after it dries for a couple hours, all right? So first, let's just get all the crystals out of there. Looks like I got everything. Got all the crystals out. Here's what it looks like right now. So you can see those aspirin crystals that are in there. Don't want to drip anything. So what I'm going to do is kind of suction off any of that solution in there because the crystals will stay behind. So I'm going to try to suction off all that stuff. Otherwise, what I can do is I can place it on my hot plate and I can recrystallize it, and then once it's all cool, I can get the brand new mass. In fact, I think I might do that. So what we're gonna do is I'm gonna add about 3 milliliters of ethanol, 95% ethanol. So I'm gonna add that to my hot plate here. 1, 2, and 3. Okay. Now let's turn the heat up on that just a smidge. And then what I'm gonna do is I'm gonna let it heat for a little bit, kind of redissolve into that ethanol. Then I'm going to add 6 milliliters of water. And we're kind of just gonna do that same dance again. So I have my water. I'm gonna put it back into this ice bath right here, let it cool down. Once it's cooled down for, again, like 10 minutes, what I'm gonna do is let it dry for a couple hours after that, and then I'll show you the next step. I'll tell you how much we actually get out of this, and then pour through some calculations with you. So we're gonna let this sit for about 10 minutes, and then we'll be back in about 2 hours. All right, guys. What up? We're back. It's another day. I didn't do, I waited way more than 2 hours, but I just wanted them to be perfectly dry before I measured out how much aspirin that we made. So that's what we're gonna do right now. We're gonna take this funnel out. Got my spatula, and I'm gonna scrape directly into the evaporating dish because I already have it on my balance. So I'm gonna get that mass there, and then we're gonna see the mass with the evaporating dish and the aspirin to do a subtraction by difference. Okay, so now that I have that directly into my evaporating dish, I can see I actually didn't make a whole lot, which is kind of sad, but we'll see. So I have a final mass of 37.57, it looks like, grams. So remember, initially we had 37.46 grams, so I only made about 11.11 grams. So later on, you're going to calculate your theoretical yield and your percent yield.
So theoretical yield is based off of the 0.53 grams of salicylic acid that we put into the reaction. How many grams of acetylsalicylic acid should we theoretically make? And then we only got 0.11 grams. So how much did we actually yield off of that? Was it real bad? When you're doing this organic stuff, you are really looking for like a high yield, something in like the high 80s, low 90s to mid 90s, something like that. There's always going to be a slight loss, but we're trying to minimize that loss. So it's up to you guys to determine how much we actually made and what's our percent yield. So here's how we're going to do that. We take our, first you have to get the moles of salicylic acid. Take the grams that we put into the equation and divide by the molar mass. You can look up molar mass of salicylic acid, find the chemical equation, and find the molar mass using your periodic table. Same thing with acetylsalicylic acid. Salicylic is that SA, acetylsalicylic is that ASA, okay? When you're finding the grams there, it's a simple two-step conversion. Or actually, in this case, it's a one-step conversion because we already have the moles there, okay? Take your answer from number one, those moles, that's what that one is down here, okay? Divide it, or actually, you're going to multiply by the mole ratio of salicylic acid to acetylsalicylic in the balanced equation. In your lab report, it tells you what you make out of that. Also, you could see what you make when at the beginning of the video, I give you that equation. I give you all the elements that go into it. So write out the formulas there and see if you can balance it and get that mole ratio. Then multiply by the molar mass of acetylsalicylic acid. That'll get rid of moles through everything, and then you're just left with grams, which is what we're looking for, okay? Once you've done that, you have your grams, your theoretical, what you should actually make, the most you can make out of this, find your percent yield. We got 0.11 in this case. Divide that by your answer to number 2, that's the grams acetylsalicylic. Multiply by 100, and that's your percent. So those are the math equations that you guys are going to do in your lab report. There is one other thing that I need to do with you guys, and that is our iron test. So the iron test in this case is used to determine if there's any phenols in your sample. So we're going to use a control in this case. The control that we're going to use is the salicylic acid. That does have that OH, that hydroxyl group, which is the phenol when it's on an aromatic ring. That is right here. This is salicylic acid. This powder right here is a Bayer aspirin tablet. Okay, so it is acetylsalicylic. It's aspirin. What we're going to put in this test tube right here is what we made. So let's get a little sample of this bad boy. Looks like a good combination of both of them. To be honest, it looks like crystals, aspirin-wise, coloring acetylsalicylic or salicylic acid. So I don't know if we got really good results, but it's the best we could do. So iron test. First things first, we dissolve this in about 2 milliliters of 50% ethanol. That ethanol is going to dissolve the hydroxyl groups off of there, and it's going to make the reaction with iron more significant, okay? So let's put about 2 mils in. 2 mils. Now, we're only going to do a couple drops of the iron. You don't need that much for it to react. And then we'll make some observations on what we're actually seeing and what it actually means. Okay. So this is my iron chloride. The cool thing is, once that chlorine hits the 50%, the chlorine is going to dissolve into the water 50%, leaving that iron 3, that 3+ ion. And that's what's going to react. So we can see it's purple. So let's pause here for now. That first test tube right there is that salicylic acid. So when you have those phenols in there, it forms that purple precipitate that's coming into the solution. So let's see if our aspirin is actually aspirin or if we made a horrible, horrible mistake. pro level. Not really. So if you take a look, I have a little of both in there. So you can see that orange tinge to it, but those crystals at the very bottom, those large crystals in there, still some leftover salicylic acid. So I kind of got a perfect combination of both, which means that we have a horrible percent yield and we really didn't get what we should have gotten. So all in all, it's okay. You know, it is what it is. Otherwise, tell me what that actually means in your iron test observations, and otherwise do those calculations, see what we got. I'm assuming it's horrible. Let me know in the Google Classroom. All right, guys, have a great day.